Hello, this is going to be the second animation tutorial for Maya, and in this tutorial we are going into expressions. We're going to use expressions to animate an object, or at least we're going to create an attribute, like a translate attribute, a transformation attribute, but then all other stuff will be connected to it, and through animating a single attribute, we're going to animate an entire object and all of its transformations. So in this tutorial we're going to look at two types of doors. One is a sliding door, okay, and very simple, like so. And right now the frame of the door and the glazing of the door, this is called glazing in architectural terms. Otherwise you would know you would know this object as a glass, but we call it glazing, general term. And then this will open in the other direction. And when we look at the other door, it is basically a basic room door. It rotates, pivots around an axis. It has a handle on both sides, and that's about it. We're going to animate these two doors, but instead of animating them separately, individually, all of these pieces, we're gonna create some hierarchies, object hierarchies, and then we're going to create an attribute or a few attributes for both of these doors and animate that attribute instead of the transformation properties of the object. Okay, so when we look at the outliner, you can see that I have extensively and carefully named all of my objects. This is very important. Do not leave these object names as shapes, poly meshes, whatever. Do not just leave them as they come when you create them, or as you combine and merge vertices and do stuff like that. Do not leave them with names created by Maya. Name them something that you understand. Name them shortly and name them appropriately. So when you look at this system, for example, these are the objects that we are not going to animate. This is just a window frame, okay, and this is window glass, and these are the objects that we are not going to animate in this system, but these we will. So this is, let's look at this one first, door 2A, and this is door 2B. Door 1 is over here, so let's forget about that. And this is door glass B and door glass A. So what you can do in Maya is that you can nest objects, you can create hierarchies. Basically this object is fully separate in terms of its the root object, in terms of the root object, which is this, and its shape, the shape associated with it. Both of those things are fully separated from all other objects in the scene. In the outliner, it stands alone. It is individual, but you can still put it inside another object or put it in a hierarchical relationship with that object. And it's very simple. You just click it with middle mouse button, click and hold and drag it over this, and do the same thing for glass B as well. So right now, if you click these plus icons, you can see that door glass B is the child of the parent object, door 2B, and door glass A is the child of the parent object, door 2A. This is going to come in handy in the future, especially when you're creating complicated relationships, complicated animations between all other objects. And this hierarchical relationship is very important in both Maya and lots of other 3D based game engines like Unity and Unreal Engine as well. For example, when you're creating blueprints in Unreal, this is exactly the same type of hierarchy that you're going to create between your imported objects. Okay, so what we intend to do here is basically we want to move these objects in a certain direction. For example, this is going to slide in this direction and this is going to slide in this direction, and as you can see, if I select the parent object, all the child objects will move with it. But if I select the child object, I can still move it separately. Basically, it is a dependency structure. In any case, we want to move these doors to either side, and we want to do it not by animating two different values, like animating door 2A and door 2B separately. We want to do it with a single animation keyframe, or a set of keyframes. Okay, that's the idea. So let's get these to their initial states, and what I'm going to do is select all objects in my scene. And I'm selecting all objects in my scene right now, but in the future this might depend on a number of things. But right now, all of the objects concerned can just have their transformations frozen, and that's what I'm going to do. Because if you look at this object, for example, it has a history, it has polycube, and it has a translate function. Its pivot is in some random location. I don't want any of these. I want to fix these issues before they become a thing in the future. Especially if I'm exporting these objects to a game engine, I want to fix these problems. So I'm going to do exactly that. First of all, I'm going to start by putting these pivots down here, right in the middle of these doors, and on the line on this axis, because I have designed all of this system on this axis. Okay, this is a very good modeling practice. Get used to this. Don't just leave your pivot anywhere. Okay, then I'm going to both delete history and freeze transformations, so this object is zeroed out and it has no history. It is properly named, it is fully ready for animation, and I'm going to do the same thing for literally every object. Okay, put the pivot in the middle or wherever it needs to go in terms of this object, not center object, sorry. Freeze transformation, delete history, name it properly, we're ready. Okay, do the same thing. As you can see, all of these things are in lots of different locations. Freeze transformation, delete history. Do the same here. Delete history, freeze transformations. These are already maybe freeze transformations. This has a weird pivot. Let's fix that. Frozen transformations, it's all zeroed out. It has no history. That's good. We're good to go. Let's do the same thing for here as well before we get to the next step of animating the sliding doors. This is already here. So is this. But this has some transformations applied to it, so let's zero them out. Okay, let's look at the door. Okay, so this is going to become very important later, because right now, whether or not I control it from here or through an expression doesn't matter. The pivot point dictates the animation of the object. So my pivot is here, but as you know, doors do not rotate from their middle points, right? I want to rotate it from a hinge. Menteşe in Turkish. Hinge. The hinge will be placed here. It will be placed outside the door frame, right around here. I didn't model the hinges. You can model the hinges. Some games will have that level of detail, but in this case I didn't bother with modeling the hinges, but you can. But doesn't matter, the door will still have to open from a position where the hinges will be placed. In this case, opposite of the door handle, right next to the frame, facing outside. Okay, so the handle, the pivot, should be around at this point. Okay, around this point somewhere, right between this corner, this position right here. That should be the hinge, because if you try to open it from here, Yeah, that's not very good, right? Okay, so let's go with it. Use snap functions, X for snapping to the grid, V for snapping to the vertices. I'm going to snap to this vertex first, but then I'm going to move it here. Okay, hit insert to apply the transformation of the pivot. Okay, now it opens up properly. As you can see, the door handles don't come with it. Let's check the door handles. Okay, so this one is in the middle. Let's look at the other areas. So the door handle, this is the panel. I named it plate. I don't know the proper English term for it. We call it kapı kolu aynası. This is called ayna in Turkish, as in mirror in English, but it's not translated as mirror, as an object in English. In any case, this will be a fixed portion of the door handle. It's not going to move, it's not going to be animated, but I have modeled it separately because I could probably apply different materials to it, or might change it later on. Okay, so this handle plate and this handle plate are also separate objects. Do they need to be separate objects? I don't think so. Let's combine them and delete history. And when you combine objects, Maya will automatically center the pivot on them. Okay, so let's check. As you can see, the pivot is centered on these short cylindrical objects. Okay, these are cylinders. They are not special objects or anything. They are just modeled that way. In any case, this is good as a pivot as any. So you might be asking the question, okay, but why are we leaving the pivot here? Because we're going to put this object, let's name this handle plate. The 3 is not necessary anymore. We name this object handle plate and we put it under door 1. Okay, so door 1 was this, the entire thing, and now it also contains handle 1. Handle plate. Okay, and handle plate, since it is hierarchically connected to door 1, we do not need to modify its center pivot, because whatever this door does, this is going to do exactly the same thing in relation to it. So let's see what that means. As you can see, it moves with it. Doesn't matter if I change this pivot or not. Doesn't matter where this pivot is. I can play around with this object however I wish. It is going to stay perfectly in relation to that object. Okay, that's the idea. So you do not need to change the pivot position of this object, but when you look at the door handle, handle 1 and handle 2, right? There are 2 handles, one on both sides. Now, speaking of doors, you might experience this. You might try this out in your own homes, in your own apartments. Check out any door. Okay, put your hand on the door handle and turn it, and you will see, if you put the door in an open position and check the both sides, when you pull the handle on one side, the other part will not move. That is by design. That is the engineering of a basic door lock or a door handle. Okay, the door handles will not move simultaneously on both sides. So you can exit the door by putting your hand on the door handle and turning it, or you can enter a door by putting your hand on the handle on the outside of the room and turn it, but the other handle in both cases will not move in modern door handles. There are exceptions to this case, but in our situations we're just trying to learn animation, so we are going to assume that these handles are directly connected and they move at the same time. Okay, so let's combine them as well. But as I have said previously, when we combine them, Maya puts the pivot in the center location, but the same problem occurs here. We want to at some point move this door handle, but the pivot is in the wrong location. So if we want to, rotate this handle, we would expect it to rotate from here, but right now it's going to rotating from the center. So we need to move the handle once again, and we move it here using vertex snap function. Okay, and if you're asking about these models, you can just as easily model them yourselves. Most of you already know how to use Blender to a certain extent, and I have shared extensive modeling tutorials in just a one tutorial, but it is more than enough to model all of these. So basically this is all snapping to the grid. Okay, these are all proper values. They are not random, they are not modeled willy-nilly, okay, without using proper dimensions. If I set this to 200, meaning that since I'm dividing 100 centimeters into 200 equal portions, I'm going to get a grid of 5 millimeters. Let's apply and close. You will see that everything lines up. Okay, I'm just using basic modeling tools here, just creating a bunch of boxes, adding a bunch of slices, using bevels, extruding edges, things like that, manipulating components like vertices, edges, and faces. But this is just polygonal modeling 101. The only difference is I am doing it very carefully and on the grid. This is important, and it's going to come in handy later on. Using accuracy and precision for modeling the stuff, especially hard surface stuff that you want to animate, is very important. Because next week, not this week, but next week, we're going to get into some nitty-gritty stuff of this kind of door animation, and it is going to require lots of mathematical calculations and geometrical creations. Okay, so let's set this grid back to an acceptable range, like 10 centimeters per chunk. So that's the idea. And let's look at the handle as well. Let's rename it handle. That's it. Let's put it here under door 1, and also make sure that we have frozen its transformations, deleted its history. Let's do the same thing for handle plate as well. Freeze its transformation. History is already deleted. Let's go to frame 1. Frame 1 is right where it should be, and with it is frozen. Wall is also. Window frame, window glass, we checked all those. Let's begin animating. So what we intend to do here is basically animate this door, but also this door at the same time. So in an animation set that is not as complicated, you can animate them separately. But even in a video game, even in a game like Unreal Engine and Unity, if you want a character to approach these doors and both of them open simultaneously, you have to set a blueprint. You have to set a system that opens both doors simultaneously. Okay, because that's more effective, that is more resource efficient, and it is more easily controlled in terms of level design. Okay, so we need to connect these doors somehow, and how are we supposed to do that? First of all, let's look at moving an object in relation to other. So if I want to move this door 2A in this direction, sorry. Okay, so let's move it like 85 centimeters. Okay, nice clean number. If you look at the behind section, the interior, let's say, section of the sliding door, there is supposed to be a mechanism here that moves the doors side to side. Okay, you can observe this object or this sliding mechanism in lots of sliding doors in shopping malls, office buildings, wherever. In any case, it is going to move, let's say, 85 centimeters, and this will move in the opposite direction, minus 85 centimeters. This is the thing that we are trying to do. Now, obviously, as I have mentioned before, you can animate these separately, but the idea is to connect their animations together. So let's take all of these back and make a decision. What if we put or create a dependency for the animation of door 2B based on door 2A's animation? How do we do that? How do we connect the animation on the translate X of door 2B, and how do we connect it to door 2A's translate X animation? And what do you think we are supposed to do? We need to create an expression. So we go to door 2B, and this will be where the expression will be written, because we are trying to force door 2B's translate X into following door 2A's translate X. Let's go to translate X, okay, and we need to, oh, wait a second, we can't do that here. The channel box is not enough anymore. We have to go to the attribute editor, and in attribute editor, if you go to door 2B, you can see the same values here. This is translate XYZ, rotate XYZ, scale XYZ. Okay, so to go to translate X, say create new expression. For good measure, if you want this menu, if you want this editor handy, you can go to Windows, hit Control and Shift, go to Animation Editors, and select Expression Editor to put it into your, custom shelf. Here it is, EE for Expression Editor. Okay, now we are in the Expression Editor, and I'm not going to go into too many details about all of this stuff. This could get fairly complicated depending on what kind of an object you're writing an expression for. If you're creating particle simulations or particle systems, for that matter, let's not call them simulations, because simulation and a particle system are two very different things. They are both similar and different at the same time. In any case, if you're writing an expression for that, this is, for example, will become very important. Computing this expression, this mathematical expression, before dynamics are calculated, after they are calculated, or at the creation of the object itself. So, but we are not concerned with any of those, so we are going to look at all of these details as we go along. So what I'm interested in is the translate X function of door 2B, right? This is the value I am interested in. So if I move it, you can see that translate X is changing. Let's zero this out. So here's how expression editor works. This is really important with capital letters. Any expression you write here can only be written under the attribute, not anywhere else. And it can only be applied if it is legible and it's acceptable. You cannot put here an expression that doesn't work and hit create, and after you leave that window, if that expression is not legible, if it doesn't work, Maya will automatically delete it. So be careful, okay? Your expression, if it doesn't work, it will disappear entirely, okay? So if I do this, you would expect from any decent computer software that, I try to create it, okay, whatever. I go here, and then I go back. Now it is gone, okay? So translate X, I've written a few stuff a minute ago, a second ago. Now it's gone because it wasn't an acceptable operation. It wasn't an acceptable expression, okay? So whatever you write here, it either works or doesn't. So if it doesn't, it is going to be deleted once you leave this window, once you even leave this attribute, okay? So what are we trying to do here? We are going to try to translate X, animate translate X of door 2B door2b translate x based on the translate x of door2a. So what I can do here is very simple, and here it is. You can see the writing standard already. door2b is the name of the object, dot for separating, for categorizing its attribute, and translate x as its attribute. And capitalization here, small letters, big letters, those are important. Okay, so door2b and door2b are entirely different objects. Maya will say there is no object that is called door2 under small capitals B. Okay, there is no object like that. So door2 capital letter B, because that is the name of our object. So just copy this, okay, and space equals, let's paste the same thing but just change this to door2a. So I have just connected the door2b's translate x to door2a's translate x. So if I hit create, everything went fine, and you will see the color here has changed, meaning that this value is now not editable at all. Okay, you cannot just type in anything here anymore, because it is entirely dependent on another attribute somewhere else, or another set of values somewhere else. Okay, this is now received a dependency. Okay, so what am I going to do? I'm going to go to door2a. Let's minimize this expression editor window. So when I change the translate x of door2a, since we have made sure that the translate x of door2b is equal to that of door2a, they are moving together. Okay, they are not connected or anything. They are just doing the same animation, and we are not even doing any animation. We have not keyframed anything. We are moving objects by just setting dependencies through expressions. Okay, we haven't keyframed anything, and throughout this animation, let's say tutorial or lesson, we're not going to animate anything till the end, and at the end of our tutorial we're just going to put 2 keyframes and be done with it. Okay, so basically they are doing the same animation. Whatever value is written here is exactly applied to door2b. So let's zero this out, but I want this to move in the other direction. So how am I going to do that? Let's go to door2b again, fire up our expression editor, go to translate x. Since this is an acceptable expression, it is already presented here, it hasn't gone anywhere. Okay, and what we want to do is this. We want to turn this into an inverted value. Okay, this will be a mathematically inverted value. Parentheses on both sides, put a minus here, and while we're at it, let's add this as well, because it is going to be very important later. I'm sure a lot of you are getting, C# or some kind of other programming language classes, and you know the importance of syntax by now. So the same is applied here. Maya uses a language, an internal language called MEL. Stands for Maya Embedded Language, and it is extremely simple. It is super simple scripting language. It is nothing like C# or C++. I don't know. I can't write any of those languages, by the way. I'm not a programmer. I'm not even a scripter. Okay, but I can use MELscript. MELscript is very easy. So if you understand the basic idea of a programming language, you will understand and get this in no time. So syntax, as with all other computer-related languages, is very important. So semicolon, please. Okay, minus parentheses door2a dot translate x, edit to have it accepted. Okay, I see no errors whatsoever. So once in a while you will get errors. So go to script editor. If you receive any errors, Maya will surely tell you that there is a syntax error or whatever here. Okay, keep this script editor handy, accessed through this button. Okay, if there's an issue, it will show up there. Let's minimize this again. So we have just inverted the translate X value of door 2A and applied it to door 2B. So when we change door 2A's translate, now it moves in the other direction. Congratulations, you have written your first expression. It is simple as fuck, but it works. That's the basic idea, right? This is all we are going to do. We are going to get just one value and convert it to many acceptable values for all objects involved in our animation. That's the thing. But you might be asking the question, we are still animating something of door 2A. We are animating door 2A to get a result for door 2B. What if we want to create our own attribute? How are we going to do that? Because we are just translating door 2A, and in relation to that, the door 2B is moving. But what if I want a percentage? What if I want to set the beginning point of this animation at a relative 0 and end it at a relative 100? What if I want to create a 0 to 100 percentage range? Because for all intents and purposes, this animation can only go, you know, acceptably to like 87 to 90 range, right? This is 90 because that's the end of this supposed door slide, and I don't want to go even that distance. I want to go to 85. But what if I want to say I want this animation to go from 0% to 100%? How am I supposed to do that? So let's do it. For example, first of all, let's start by deleting all of these expressions. Right now we have an expression here, and I want to get rid of it. So what am I going to do? I'm going to go to outline, and I'm going to go to display and deselect DAG objects only. DAG stands for directed acyclic graph. It's a mathematical term. Basically, it's a graph structure which tells how all these objects are connected to each other and how they are depending on each other. Not limited to these, by the way. Maya, as you can see from the attribute editor, have lots of other DAG objects. For example, the initial shading group and Lambert 1 are also nested under door 1. They're not just only nested under door 1, but they are one of the positions they are nested under in. So if you deselect DAG objects only, you will see a lot of other objects, and here you can see expression 1 which was this, and expression 2 here. Okay, select them both and delete them. You can delete expressions that way, very handy. Okay, so let's switch to DAG objects only. And what am I going to do? I want to create an expression somewhere that animates both of these objects. What I can do is create a new attribute for door 2A. That is one option, but I'm going to do one better, because since these two doors will move in opposite directions the equal amount, one object doesn't necessarily is the dominant one. Like, these are not mechanically connected. They are part of the same system, but they are not dependent on each other. So this is the point where you have to start thinking about how objects in real life, or how the objects they are representing, are connecting each other. So this door frame and this door frame, although we are trying to move them at the same time, in terms of their representations, they are not connected, right? This object is controlled by one motor, this is controlled by one motor, they just happen to move at the same time. Okay? So if I want to do that, if there is no dominant relationship between these objects, maybe I should create another object that dominates them both and creates a hierarchy where this door 2A and its children, namely the glass A, and door 2B and its children, namely the glass B, becomes connected to at the same time. I need to create an empty object. Okay, and how do I do that? I go to create locator. Locator is basically an empty object. If you go to channel box, it is just a point in space. It doesn't have any shape attached to it. Nothing is connected to it. It's just a freestanding entity with bunch of attributes that are available in lots of other objects. Basically, you can assume that this is a group. Okay, this is an empty group. Okay, so I'm going to rename this locator to something like sliding doors. Okay, and then hit door 2B and door 2A, control click to select them both, middle mouse button click to move them onto sliding doors. Nice. Okay, so now both of my objects are under the sliding doors locator, and my locator's center pivot is also begins at this location. So let me move that to a more appropriate location, namely the middle. This is important stuff. Okay, and my transformations are already zeroed out. I have no history whatsoever. Okay, now what do? I want to add an attribute. We have attributes here. We have translate attributes for moving the object. We have rotation attributes for rotating the object. We have scaling attributes for scaling the object. And I also have visibility. It is either visible or not visible. This is a Boolean value, meaning it can be either 0, off, or 1, on. Okay? So I have all of these 10 attributes here, but I want to add my own. So if I go to the attribute editor, hit attributes, and hit add attribute, now I can add my own. And what type of an attribute do I want to add? First of all, I have to name it. So for example, what do I name it? So this is a long name, meaning that this will be the name that I will be using throughout my expressions. So it is called a long name, but keep it as short as possible, so you have to type less. So maybe sliding door. Let's go with the Maya standard. First word's letter is lowercase. Sliding door, second word's letter is uppercase, and all the words following it, door anim. Okay, so you can also override it so it will show up properly under here. So it will show up like sliding door anim, but you can add this as well. Okay, sliding door animation, overridden, nice name. And it will going to be a float value, meaning that it is a floating point value. It will have decimal points. It is not an integer. Okay, it is not Boolean like 0 and 1. It is not a vector like 3 separate values stringed together, combined together. And it's not XYZ values. It is not a string. String is just text, and enum is I don't know what the hell. So basically it is scalar, scalar, and we will give it some minimum and maximum values as well. So we want this to be a percentage, right? 0%, 100%. It will be a scalar value, a scalar floating point value between these. Okay? 0, 100. Hit OK. Go to sliding doors. And under extra attributes, you now see sliding door animation as a slider range, a scalar range of floating point value from 0 to 100. And if you go to channel box, here it is. Okay, now we have added our 11th attribute to our locator. Let's go to expression editor. Oh, sorry, this is the script editor. It was a cool transition though. Okay, so my sliding doors locator is selected. Go to sliding door anim. Remember, you can only write an expression under the sliding door under not sliding door, under the value that you intend to change. So we have a right here, that's good and all, but are we trying to change sliding door anim? The sliding door anim is not dependent on anything. We are trying to keyframe this. This is going to be from 0 to 100, and at the end of our animation we are going to keyframe this. We are not trying to create a dependency for this thing, okay? We are trying to create dependencies based on this thing. So we shouldn't be here. We should go to door 2B and door 2A. Okay, let's start with door 2A. What are we trying to animate here? Once again, translate X. Okay, we are trying to animate translate X in this direction from 0 to 85. But we are trying to normalize that value, normalize that 0 to 85 to a range of 0 to 100. That is called normalization. Okay, we're going to normalize 0 to 85 centimeter movement as a percentage between 0 and 100. Okay, so let's select translate X. What I want to do is copy this, paste it here, equals. How do we normalize? Mathematics people, we have to normalize this thing. So we have a value of something, and that will be our animation. And what that animation was is sliding doors. Let's write it. Sliding doors dot. What was the name of our attribute we have added? I don't even remember. Let's copy it so we don't lose it. Let's go to sliding doors, sliding door animation. Oh, I remembered. Sliding lowercase, door D uppercase, anim A uppercase. Okay, all connected. Let's go to door 2A again, translate X, paste it back. So sliding door anim. Okay, this will be our value. So let's try this first, see what happens. Create. Okay, and it worked, nothing is wrong. So when I go to sliding doors, let's go to attribute editor to get the slider. If I animate this, as you can see, if I go to 100, it will go to 100 because it is exactly the same value. We haven't normalized anything yet. This is just taking the sliding door animation value and applying it to the translate X of door 2A. Again, this is dependent on the sliding door, the attribute that we have added to sliding doors, so we cannot change it outside of its dependency. Okay, but that is not what we want. We want to normalize this so that 0 to 100 becomes 0 to 85. So we have to write that. Let's go to sliding door 2A once again, translate X, sliding doors dot sliding door anim. That's good. So what I want to do is, first of all, sliding door anim, we divide this by 100. Okay, let's put some spaces here for ease of visual comfort. Okay, so we are dividing the value of sliding door anim by its maximum value, which is 100, and then multiplying it by the maximum value that we say door 2A can translate from the x-axis, which is 85 centimeters. 85 times. Okay, let's edit. Now this is normalized. Maya is looking at sliding door animation attribute, dividing whatever value that is by 100 and then multiplying by 85, therefore normalizing it from 0 to 100 range to 0 to 85 range. Basic mathematics. Okay, so let's go to sliding doors. Now when I slide it all the way to 100, as you can see, it stops at 85, but it is a linear transformation. This is LERP. This is linear interpolation. Okay, we are linearly interpolating between the 0 to 100 range and 0 to 85 range. And let's go to door to A again to translate X. Let's copy this, okay? Go to door to B, select translate X, and just say minus, because it was in the other direction, right? So create, close, okay, something has went wrong. Nice, we have an error. Let's see. Let's figure out what has gone wrong. Okay, let's go to door to A, translate X, everything is fine. Door to B, translate X. It is empty. Why is it empty? Okay, I know why it is empty, because what do we talk about? You can only write expressions about the object you are writing in. So this is door to A, translate X. We cannot write door to A's translate X inside door to B's translate X. We have to make sure that this is door to B. So again, door to B translate X equals minus 85 times the sliding door animation value divided by 100. Okay, create. Okay, now we are speaking. Now let's see. Go to sliding doors. There you go. Basically, this is how you use the expression editor. Sorry. Come on. Okay. So this is how you use the expression editor. Basically, just basic scripting language, very simple scripting language, and very simple mathematics. Okay? I mean, it could get complicated depending on what you need, but this is the idea. So let's get into something even more complicated. How do we rotate this object? So we talked about how these objects are, connected to each other in terms of their parent and child relationships. So handle plate, we're not going to animate it, but handle, we do want to animate it. And this is very important, because if the handle is outside, okay, now speaking of sliding doors, the sliding doors, it doesn't matter if one object is nested inside the other, or both objects are nested inside a locator, because you can just as easily animate them separately. But in this case, this is not going to work. No way, it is not going to work unless the handle itself is nested under the door. Because when the door is opening, the handle is supposed to open with it. Okay? The handle cannot open in relation to the door and rotate around its own axis at the same time if it's not nested under the door. Okay? If it's not under the door, when you open the door, it's going to stay put. It's not going anywhere. Okay? But we want this to move with the door and rotate around its axis whenever we want it to. Okay? So that's why the hierarchy is important. This handle has to be nested under the door. And this is going to come in handy later on when you're doing more complicated mechanical animations. Alright, and we have set our pivots, deleted our history, frozen our transformations, everything is ready hierarchically speaking. So let's animate. Now we are not going to use a locator because we have just one dominant master object. Unlike here where both doors can be used as the master, this will be the master. Okay, the door one will be the master. So we don't need to create a locator, and its pivot point is at this axis, so it can rotate in the y-axis. Remember, Maya y-axis up, vertical. Okay, it is going to rotate from the y-axis, and let's do that first. Let's create an attribute for door 1, similar to how we did in the sliding doors animation. Okay, let's go to the attribute editor, door1 attributes, add attribute, and we're going to give it a long name such as, you know, door animation or door anim for short. Alright, nice name, door animation. Okay, it is going to be a float, it's going to be a scalar value from 0 to 100. Default comes with 0. Hit OK. There you go. So channel box, door animation, we have our value already. But we need to create expressions now. So what are we going to create an expression first? Remember, we are not trying to create an expression for door animation. Door animation is our controller. We have to set our expression under the attribute, under the variable that we are trying to control. In this case, what is this axis? Rotate Y. Okay, we are trying to control rotate Y. So let's zero this out. Apparently this is still not frozen, so let's freeze it out. Make sure that everything else is also frozen. Okay, everything is frozen. So let's go to door 1, hit expression editor, door 1's rotate Y. So let's copy this, equals to door 1 door anim, semicolon. Just make sure you add this. If it's one line, it's okay. If you don't add it, if it's more than one line, it's going to cause issues. Create. Now, similar to how we did at first at the sliding door, we have equalized door anim's value to door 1's rotate Y. Okay? So when we play around with this value, let's go to the attribute editor for the slider. It is, as you can see, goes from 0, which right now Maya is looking at in terms of rotate Y as 0 degrees to 100 degrees. Okay, so what if I want to set this to 90 degrees? What if I want to, you know, make sure that this door rotates from 0 to 90 by just a slider of 100%? Okay, how do I do that? Same idea applies. We go to here, we normalize it. And how do we do that? We first of all divide this value by 100 and multiply it with its maximum value that we want to put it at. Okay, so edit. Right now it is 100, but it is 90 degrees. If you can be sure it is 90, okay? It is perfectly 90 degrees. Because this value now is normalized. Now the good thing about doing this, so you might be asking yourself, why am I trying to normalize this value? Why is this important? Maybe you want to later on modify this door without changing your animation to open at a shorter or larger distance, right? So you can do this. If I want to limit its opening without changing the animation, without changing the keyframes, you can do this. 150 degrees, edit. Now the maximum opening range of this door, still controlled by the same scalar value on this slider, is 150 degrees. Okay, so you have just modified the opening animation, the proverbial opening animation. We have none so far, but you get the idea. You can just change these values. And the best thing is, you might be asking yourself, again, like you should be asking yourself a lot of things, why are we doing this in the first place? This script writing is basically what you're going to do in Unity or Unreal using nodes. Okay, same mathematics, same standards. You're going to get a, I don't know, a scalar value of some sort, and it doesn't have to be 0 to 100. It could be 0 to 200. It could be 0 to 17.956. I don't care. You can get one value that works for your animation, works for your video game, and then convert it to any other stuff depending on what type of an automation you need. Okay, and this automation can be quite necessary. All right, because you can say to your video game that, for example, some doors can only open this much, some doors can open that much, but the character's door animation is always the same. When a character triggers a door by clicking it, by standing next to it, by pressing a button, doesn't matter, by pressing a key on a keyboard, doesn't matter, the animation blueprint is the same, the animation standard is the same, but the door opening cycle will depend on that specific door. So basically your door animation blueprint will not have to change, only the type of door you're designing for your game will change. That's the idea. Okay, so more dynamic control is very useful. Okay, we understand this. So we have a handle. How does it fit into this function? How do we put this door handle into this door animation? Okay, is it going to like open at the same time? Like, is that meaningful? Let's go to handle, for example. We don't have to copy it, we can write it again. Okay, so this is the door handle, and okay, let's not maybe do that. Let's reset this. Let's go to handle and rotate it. It's on Z axis, Z minus, mind you, because door handle will move down. That's what I want. Z minus, okay? And let's say I want to move it like 45 degrees, minus 45 degrees. Okay, let's go to handle, rotate Z, and handle rotate Z equals minus door 1, not 3 O's, door 1, door anim. But we want to normalize this, right? Not minus 45 times parentheses space divide by 100 space, close parentheses, create. Okay, so basically what is going to happen is when I animate door animation slider, it is going to animate for the entire duration of this animation. You can see it very clearly, I assume. As it's going on, it only reaches the minus 45 degree position when this door animation reaches 100. But what if I want to do this? Let's go to paint. Let's grab big bold colors and stuff. Okay, so this is my this is my door, okay, and it is going to open in this direction, okay, but before it does, we have a slider of 0 to 100. I want to reserve this 10% of the animation for just the door handle, okay. In that 10%, door handle will go from 0 to minus 45 degrees. Then during that 90%, okay, the rest of this animation will occur. That's what I want to do. How do I do that? First of all, let's get rid of this door handle problem. What I want to do is very simple. Let's reset this. Okay, go to handle. All right, and then open up our expression editor and try a let me give you the wrong example first, the wrong way to do this. Okay, so how do I limit a value to 10 in a 100% range? How do I limit a value to 10? I can write an if-else expression, right? So I can basically do this. And if you want to see the expressions used here, the values, not the values, but the the strings used here, you can just check the documentation of Maya. So basically, I mean, this is 2013 for I don't know what reason, but it hasn't changed since then, so you can use this. So this is the if-else expression. You can see it is very similar to literally every other programming language out there. So this is the if-else expression. Syntax matters. Check it out. Okay? So basically what I want to do is write an if-else expression that limits the value to 10 if door1 door_anim is equal to or smaller than 10, open braces, these are called braces, in Turkish it's called süslü parantez, I think. It's a weird shitty name, but whatever, let's go with it. Okay, if door1 dot door_anim, which is our master value, it's not here right now, but whatever, is either equal to or smaller than 10, then handle rotate z is door1 door_anim. That's it. Semicolon. But close braces else. Handle rotate z is still 10. Okay, it is not going to change. It is not going to go above 10. This if else makes sure, and remember to do this as well, close braces. Okay, so this is going to make sure that door1 door_anim will act independently, or will act accordingly, sorry, in the 0 to 10 range, or anything less than 10. Let's be sure about this mathematically. This is not a 0 to 10 range. We have not gotten through that. This is just less than 10. It could be a minus value as well. We know that we are limiting that value from 0 to 100, so we are comfortable about that, but the idea is this is less than 10. Anything less than 10, the door_anim will be that value. Anything more than 10, it will just be 10. Okay? That's it. Edit. But let's check the script editor because I saw a red flash. Let's see. Okay, I figure out the problem. This was the issue. Okay, it's lesser than, I mean, if you switch these, if you switch this the wrong way, it's going to cause issues. So basically it's lesser than equals. It's not equal lesser. So that's what I mean by syntax matters, because it is going to cause tremendous amount of problems. Okay, so in any case, here's what we did. We limited this door_anim slider to just 10%. Okay, and then said handle rotate z equals 10. All right, that's it. So handle rotate z now works like this. Oops, it doesn't work like that because we haven't animated it. Let's go to door1 and use the door animation. Okay, it just moves 10% and it completes that transition during the 10% mark. Okay, beyond this it doesn't do anything. Okay, and we can further normalize that. So if you go to door handle again to rotate z, so right now handle rotate z is 10. Okay, and what we are doing is we are limiting handle rotate z to just 10 degrees, but we are not normalizing it. So we need to write an expression that says this will be, for example, minus 45 times, in parentheses, door1 door nm divided by 10, and the same will be here as well. Or let's say 45, okay, because that's much easier. Okay, edit. So it will be 45-degree rotation for the first 10% of this door animation slider. The first 10 points, 10 numerically 10, will be limited to its door handle. But this is the hard way, and this will cause issues later on. If you want to do further than that, this will cause issues. So let's forget about this. Remember, this was the wrong way to do it. If instead of using an if-else expression, let's use clamp. Clamp is exactly what it says. It clamps the value to a certain extent. So I'm going to say handle rotate Z equals clamp, parentheses, the minimum value of this clamp range, which is 0, maximum value, which I want to be 10, and the value we provide, which is door1 door nm, parentheses closed, semicolon, edit. So now we are doing the exact same thing. We are just clamping this door1 animation value to a range of 0 and 10. Beyond that 10 range, everything is read as 10, okay, in the context of the door handle, handle dot rotate Z, okay. Oh, but remember, we still need to put on that normalization in effect. So go to rotate Z and do this, minus 45 times one more parentheses divided by 100 or 10, sorry. Hit it. Let's check it out. Nice. So what's going on here is during the first 10%, the door handle is moving to a minus 45-degree angle. That's it. But here's the idea. What if I want to start rotating this door after that 10%? Because that was our plan. The 10% is reserved to the door handle. That is the lag, okay? During the 10%, during that 10% transition, the door will not move. It's not going anywhere. Then it will start moving. How do I do that? Let's write it. So, door 1, expression editor. Okay, let's check which value we're talking about here. Okay, I mean, we don't have to check it. We already wrote an expression for it for 150 degrees. Door 1 rotate Y. Okay, but now we want to write it between a range of 10 and 100. Okay, so how do we write an expression that only controls this door between a range of 10 and 100? One way to do it is this. We subtract 10. Okay, so door 1 rotate will only move from 10% to 100%. So we need to clamp that value somehow. But also at the same time we have to stop it from moving until it reaches that value. Okay? So we can do something like this perhaps. Let's try it. Clamp. Or let's begin with this and we'll go from here. This value equals okay. Let's see what happens. Now, here's the problem. Right now, it is starting rotated at an angle of 10 degrees because we are clamping its minimum value to 10. So we need to also add this. Let's do this minus 10. Okay? All right. So once we do this, it is rotating like so. But now this value is now normalized. Let's say we still have to, and let me check. Yeah, it is only moving after 10 point mark. That's good. We still have to normalize it. So we were talking about 150 degrees, right? We want a 150 degree rotation. And the range will be now 90 instead of 100 because we have normalized it to a value range between 10 and 100. Let's hit edit. I wasn't too sure if everything is working. I think it's working. Yeah. Okay. That's good. Now we have also normalized this value as well. So what is happening here is between the door animation values 0 and 10, only this door handle is moving. Then for the rest of it, the door handle is staying the same and the door is opening to its fullest extent, which we have defined as 150 degrees. We can change it if we want. We can just type in 120 and its range will be set at 120 degrees, okay, 120 degrees. It's our decision, basically. But let's not stop here. One final thing. While this animation is still going on, I want this handle to return to its original state. Okay, at one point during this door animation, let's say from the 30th frame to the 40th frame, I want this animation to revert back to 0. Okay, so we have to go back to the door handle. Now in the door handle, instead of trying to write it here, we're going to create a new attribute, but we're not going to animate that attribute. That attribute will also be controlled by these expressions. That attribute will be a handler object, let's say. It will be an intermediary thing that we need to add. So let's go to door 1, and we want to keep it here. I mean, we don't have to keep it here, but let's keep it here. So every expression, every new attribute we add stays in the same directory. We add a new attribute. It will be a float once again, okay? And the minimum will be 0 and the maximum will be 10. All right? And then we're going to give it a long name like handle anim. Okay, handle animation, it will be called in its nice name. Let's add it, close, handle animation right here. Now what I want to do is get this expression from here to the handle anim. Okay, so basically door 1 handle anim is -45 clamped to this. Okay, but not only that, I now have to add an if-else expression so that after completing this, around whatever value I want from the door animation, it will revert back to its original state. And what did we talk about? We talked about how it would go from 30 to 40 range, doing the same thing, only backwards. Okay, let's write it. So basically, if, open parentheses, door 1 handle, no, not handle anim, door anim is less than or equal to 30, okay, open braces, then this is what's going to happen. Exactly the same thing. Only we are now controlling an attribute that will in turn control the rotation of the handle. Okay, this is a new attribute that is under the door 1 object, but it will be used to control the handle object's rotation. Okay, then close braces else, open braces again, door 1 handle nm equals to minus 45 times clamp 010 door 1 door nm, but let's get this in more braces, minus 30, okay, sorry, this is a dot, it shouldn't be a dot, okay, nice, close braces one more time, divided by 10, but do we stop there? No, we shouldn't, we have to give a minus 10 to this. Now hopefully this will work. Okay. Sorry, I forgot. We shouldn't be normalizing these values, because we're going to do that in the door handle. I was checking my notes. We're not going to normalize these. Those operations will be carried out by the door handle rotation. This handle rotation expression will carry out that operation. But this is how we do it. So close braces, and if we have done nothing wrong with the, yeah, everything okay, syntax okay, now we have our handle animation, hopefully. Let's copy it. So it didn't work, so it has a syntax error, I guess. Because it is missing some brackets, sorry, parentheses here and there. Did it work? Let's check. It still didn't work. Again, missing parentheses. Now it did work. As you can see, the color has changed purple. Now this handle animation is connected to some stuff, and once again we cannot change it. Okay, this is dependent on other objects, so we cannot animate it, we cannot change this value, but we can use it, we can call it. Okay, this will be very useful. So let's go to handle. Okay, handle rotate Z, and instead of using this clamp value here, let's use door 1 handle nm. Okay, and we have to put it in parentheses, I guess. Okay, so basically this should do the same thing. Let's see. If you go back here, yeah, it is exactly doing the same thing, but look what happened. Now, although we didn't animate or expressed handle directly, okay, we only added this function right here, the handle is moving backwards to its original state. So what's going on here? Why is this happening? We have to look at it from a mathematical perspective. So let's follow the numbers, okay? It's always good to follow the numbers. Let me reposition everything. Let's get rid of the script editor. Now that everything's working, we don't have to check it anymore. So let's go to door 1 and go to handle anim. So when the door animation is at 0, everything is 0. So for example, let's follow it from the 0 point. If door anim is below 30, which it is because it's 0, then door 1 handle anim, which is this new attribute that we have added, okay, will be clamped to between 0 and 10, and the value will be this, okay, to door 1 anim. So the value is 0, it will be clamped between 0 and 10. Obviously it will be 0 because it falls within that range, okay. Then this door handle anim is set at 0. Then we go to handle rotate Z. Handle rotate Z looks at handle anim, which was 0 if you remember, divides it by 10, gets 0, multiplies it by -45, and again reaches 0. So right now it is 0. Let's go back. Go to handle anim once again. If it is, let's say 10, we are still dealing with this part of the if expression because it is below 30, clamped to 10 because the value is 10, and then handle anim is 10. Okay, let's set it to 10. It is 10. And then we go to handle rotate Z. Now the handle rotate Z is doing a basic, very basic normalization operation, which is dividing handle anim by 10. It is its maximum intended value. 10 divided by 10 equals 1, multiplied by -45 equals -45 degrees. That's it. Rotated the handle object, rotated on the z-axis for -45 degrees. Let's go to the beginning point again. Let's assume that this is 20. Okay, now 20 still falls below the 30 range, and it is here 20, but it is clamped to 10, so the operation is exactly the same, and this will go on until we reach 30 or above 30. When it is above 30, let's say 35, now something else is happening. Now when we look at the if operation, it is no longer under 30 or equal to 30, so we look at this part of the equation. So door 1 door anim minus 35, we subtract 30, okay, which is surprisingly same value. I wonder why. Okay, because oops, we don't want to change that. 35 minus 30 equals 5, and this 5 falls within the range of 0 to 10. So if let's say this is 60, the 60 will be subtracted 30 and still will be clamped to 10. The operation is the same. Okay, so basically we are doing the same operation only at a different range level. All right, that is the basic idea, but we are not stopping there. We are also subtracting this from 10 to make sure that it goes not from the 0 to 10 range, but 10 to 0 range. If we subtract anything, if we subtract 10 from a 0 10 range, it will go to 10 to 0 range. Basically we are taking that operation and inverting it numerically. That's the idea. So this 5 is no longer 5, but when it is 0 it is 10, when it is 10 it is 0. Okay, when I plug 40 here, this turns 0. Why? 40 minus 30 is 10. 10 minus 10 is 0. Okay, so we are inverting this handle operation. I mean, you can basically do the same thing without using this attribute, but this is really useful for later, because you can create these additional attributes to control a lot of objects at the same time. And this will be easier to manipulate and visualize instead of, writing these long ass expression inside parentheses. Okay, so this is the idea. Basically, we are now using just one single slider from 0 to 100 range, and that 0 to 100 range slider is controlling the handle, its movement, both in the positive direction, or this is basically a negative direction, but whatever, the negative direction and the positive direction, all during the animation. And remember, we haven't keyed anything. Okay, so basically I can do this. I can go here and say key selected or set key, go to, I don't know, open it in the span of like 2 seconds, set key again, open up our graph editor. Okay, it's just basic ease out, ease in. That's nice. So when I do this, and maybe let's stop for just 1 second. Sorry, this is not 1 second, by the way. This is not 2 seconds, by the way. This is just 1 second. Let me fix this issue real quick. Okay. Wait for, I don't know, just 24 frames, which means 68. Set key. Go 2 more seconds, which means 68 plus 48 means 116. Set this to 0. Set key. Let's go back and watch it. Door opens, door closes. Now you can also do things like, obviously you can even complicate it even more so than this. When the door closes, the door handles move in the opposite direction. That does the same animation, only in backwards, only in reverse. You can stop that. You can stop that from happening if you add more stuff here. Okay, so that's entirely possible. But it's, I mean, this is just for, basically understanding how animation works with dependencies, and can be controlled from a single source with just mathematical expressions. And these are easier to do, much easier to handle in modern game engines, node-based graph editors like Unity, like those available in Unity and Unreal Engine. But for the purposes of this class, for the purposes of this course, you're going to do this in Maya first. Then if you want to try it, you can do it in Unreal as well. I can show you the Unreal version of this. In any case, this has been the sliding doors and the standard rotating door. Okay, you'll model these doors yourselves. Okay, use good modeling techniques, and then using the expression editor and writing expression and taking care of this hierarchy, this object hierarchy, you're going to animate 2 doors. Good luck and have fun.